Good morning all. Today we are going to study moment of inertia. So in the beginning itself we have to note the definition. It is nothing but the product of mass and square of the distance from the axis of rotation. So this is moment of inertia is always linked to a rotational motion, and moment of inertia is nothing but product of mass and square of the distance from the axis of rotation. So how do you write the expression? So we put moment of inertia as I is equal to product of mass. So you have to multiply two things. What are the two things? The mass m and square of the distance from the axis of rotation, that is r square. So moment of inertia is nothing but I is equal to mr square. Now what is the unit, SI unit? For mass it is kilogram, and for distance it is meter. So since it is r square, it is meter square. So kilogram meter square is a unit for moment of inertia. There are two theorems, two main important theorems in moment of inertia. They are parallel axis theorem and perpendicular axis theorem. So we'll look into the parallel axis theorem. It states that the moment of inertia of a rigid body about any axis is equal to sum of the moment of inertia about a parallel axis passing through the center of mass and product of mass of the body and square of the distance between the two axes. So this sum of, so you have to write moment of inertia of a rigid body about any axis. So I is equal to, so what does it tell? Sum of what all things? About a parallel axis passing through the moment of inertia of a parallel axis passing through the center of mass. So it will be ICM plus, and what else? Product of mass and square of the distance between the two axes. So if you say that A is the distance between the two axes, then it is a product of mass and square of the distance between them. So your parallel axis theorem is expressed as I is equal to ICM plus MA square. So if you take the whole masses, like small m I have written, you can take the whole mass and you have to write it as capital M. Okay, if you give the notation as capital M, that is capital M A square. Now we have to look into the proof of the parallel axis theorem. Here what I am going to do is, I am going to now find out the moment of inertia about AB. This is AB. Okay, this is AB. So for that what we are going to do is, we are going to consider certain things. Now you can see that I have two axes. One is Z prime, an axis passing through the center of mass, and moment of inertia I have given it as ICM. Okay, it is ICM. Let ICM is the moment of inertia of the body about which one? Is Z prime axis passing through the center of mass, and I is the moment of inertia about another axis AB. I is the moment of inertia about AB parallel to Z prime. Okay, which is at a distance A. I have marked that also here, A, from it. Now I am going to put a point P. Okay, here consider mass, a point of mass M, which is at a distance. What is the distance from AB, capital AB? So this is A and this is B, right? So it is at a distance y plus AP away from AB. So I have to write, consider point m at a point P, distant y plus a from the axis AB. The moment of inertia. Now we have to calculate the moment of inertia about the mass at P. Okay, we have to calculate mass at P. So what is it? We know that from equation 1, what is it? Moment of inertia is nothing but mass into square of the distance from the axis of rotation. So it is m into y plus a the whole square. Now it is just one small point which you have considered here as P. You can consider from infinite number of points all over the rigid body. Okay, so we can take the total mass. That means the moment of inertia of the whole body. Moment of inertia of the whole body about AB is obtained by summing over similar terms. That is, I is equal to sigma. How do you write summing? Summation m y plus a the whole square. Now we have to just evaluate this term. So you know a plus b the whole square is a square plus b square plus 2ab. So we employ that formula here and we get sigma m y square plus sigma m a square plus sigma 2ab, that is 2m ay. And now we can see that my my square, just imagine this is my square. See, my square means this, it is a distance here. Okay, so that is ICM. We have sigma m y square is equal to ICM. Similarly, sigma m a square can be written as a square. A is a constant, so we have sigma m. So it is sigma m is nothing but your total mass of the rigid body times a square. So again we have sigma 2m ay. How do you write that? This is equal to 2a is a constant as I told before. Then what you have inside is m into y. Now what is m into y? That is the next question which we have to ask. So m into y is the moments of all mass points. So my is sigma my is a sum of the moments of all mass points, which means that if you add all those together, see, you have a moment here. So I'll just show you here. If you have a moment here, you have an opposite, just opposite to that you have another moment. So it just cancels off. So for each point you have a opposite point. So that when you sum it up, you get 0. So you can write sigma my is a sum of all of the moments of all mass points about an axis passing through the center of mass. Therefore, it to give the sum as 0. This point has to be noted. Therefore, the equation, see, I'll put it as, label it as A. What will the equation A look like? B. Here, what will the equation B look like when you put sigma m y square ICM, sigma m A square as m A square, and the sigma 2m AY is equal to 0, right? So now equation B can be written as I is equal to ICM plus m A square. Okay. So this is what our parallaxes theorem states. So please do study this. It's quite important to know the proof also, and it's quite easy also. Now looking into the perpendicular axis theorem. Here we have to again state the perpendicular axis theorem. It is very simple. It is stated as the moment of inertia of a rigid body about an axis perpendicular to its plane. The other one was about an axis parallel to its plane. Here it is perpendicular to its plane. And it is equal to, again, it is the sum of moment of inertia about two mutually perpendicular axes. Where are they lying? In the plane, and also they must intersect each other. Not only that, it should also intersect where the perpendicular axis also meets the plane. So I repeat again, the moment of inertia of a rigid body about an axis perpendicular to its plane is equal to, so this is the, suppose Z prime is the moment of inertia which we have to determine. This is perpendicular to the plane, is equal to sum of the moment of inertia about two mutually perpendicular axes lying in the plane. So our two mutually perpendicular axes are x prime and y prime. Okay, so what we can write? Iz. So if you put that about z axis, it is Iz is equal to sum of the moment of inertia about two mutually perpendicular axes. Which are mutually perpendicular? Suppose Ix is the moment of inertia about x axis and Iy is the moment of inertia of the y axis. Then you can write Iz is equal to Ix plus Iy. Now we have to look into the proof. Consider the particle of mass m on the plane of a rigid body at point P. See, I have drawn here. Okay, at point P. So you know the coordinates to represent P is x and y. Now we have to find the moment of inertia about Z prime. This is Z prime. So what we know? It is equal to mass into distance square. So distance square must be, how do you calculate it? You have to put drop a perpendicular there. Then you know what is OP equal to. So we have OP square is equal to x square plus y square. Therefore, moment of inertia of the particle about OP Z prime is nothing but mass at the point P, which is equal to m into OP square. So it is nothing but m into, so substituting for OP square, it is m into x square plus y square. Therefore, moment of inertia of the whole rigid body, you have to sum all over the masses. So you have to put a Iz is equal to sigma m x square plus y square. All this is equal to sigma ms. You can just open up the brackets. Sigma m x square plus sigma m y square. All this is equal to moment of inertia, mass into distance square. Moment of inertia along x direction and moment of inertia along y direction. So you get the perpendicular axis theorem as a sum of moment of inertia of two mutually intersecting axes perpendicular to each other and also intersecting each other at where the perpendicular axis meets them. Okay, so this is the perpendicular axis theorem. Thank you.